We have a MacBook Air. It's an A1466. So the A1466 is the it's a model number that Apple uses from 2012 up until 2017. So the A1466s, they are also they use the MagSafe too. Um, so in terms of the charger, so it's going to be a MagSafe too. So it's not going to be a MagSafe one. So the A1466s, they all uses MagSafe 2 45 watts. And then in terms of their parts, you can use virtually all of the parts between 2012 up until 2017. The parts are interchangeable. However, one of the commonest parts that are not interchangeable on the 2012, it's the IO board cable. Uh, so the IO board cable for the 2012, it's going to be slightly the 2013 and above will be slightly longer than that of the 2012. So that's the one part that's not compatible. However, the screen is compatible. The screen is compatible. The drive is not compatible. You cannot use the drive on the 2012 on the 2013. From 2013 up until 2017, the parts are completely compatible. You can swap between anything and it's going to work. So the description of this one, it says it doesn't pick up Wi-Fi. Now, when you're working with devices that do not pick up Wi-Fi, one of the easier way, so with a job like that, you do not need access to the client's password to go to desktop. You can get access to the Wi-Fi option by holding down the Alt key. So what we are going to do is we are going to hold down the Alt key and then start the device. And sometimes you may have an issue that's software related. It may be that you're having a conflict of software. And if that is the case, also by holding down the Alt key in the boot option environment, you will not have the same issue that you will have when you get to your desktop. So what you're going to do on this one is and by the way, this has like I said, that most of the devices that we get, they go through assessments by the companies, and they try their own fix, and when they are unable to do so, then the device will come to us. So this one, the client, the company has confirmed that they have replaced the Wi-Fi card. Now, on older designs, Wi-Fi cards are removable. On newer device, Wi-Fi cards are embedded onto the board. So we are going to this is a MagSafe 2, and then just a quick one on the behavior of the MagSafe 2. And then one of the ways you can easily confirm or differentiate between a Chinese charger over or a non-original Apple charger over an Apple charger. So the behavior that you will get is when you connect an original Apple charger to a device, there is a slight delay, which is ideal, which is better for the device. So there will be a cross check having to confirm the state of the device before the device itself will output voltage. Now, this is very safe because that way, if there is any issue on the board, then the charger itself will not output voltage to the machine, thereby preventing the machine from any type of further damage. However, if this was a generic charger, when you connect it to the device, it immediately enables communication with the computer, which is wrong for the computer, which is bad for the computer. Now, how do you differentiate between both? An original charger, immediately you connect the tape to the device, there is a slight delay. So you see this cord out here. So here there is this cord out here is supposed to be there's supposed to be an LED coming out from there. When you connect the charger, what will happen is there will be a slight delay. Then the LED will come on. It will start from green and then move to amber. Now another thing, okay, just on that, the MagSafe 2 will generally move from green to amber. Now, that does not necessarily mean a change in state immediately. What I mean is this: the MagSafe one, when you connect it to a device, when it's green, it means that it is not charging the battery or that the battery is fully charged. When it is amber, it means it's currently charging the battery. Do you understand? So that is your MagSafe one. MagSafe one, when you connect it to a device, the same pulse at interval is the same thing that you get. If it's an original charger, you get a slight pulse when you connect the charger, and then it will turn green and remain green if the battery is full, or if the battery is not charging, or if the device is stuck in SMC reset mode. Now, with MagSafe 2, that is different. MagSafe 2 will, when we connect the charger, it will quickly after there's been communication established, it will transition from green to amber. That does not necessarily mean that it is charging the battery. If you go onto your battery info, it can still say plugged in, not charging. Do you understand? And then, so it might not necessarily mean that it is charging the battery, and even and it and when it is charging the battery, it will still stay amber. Now, when the battery is fully charged, then it will move to green. So it starts from green and then immediately transition into amber. If that's a MagSafe one, when it transitions from green to amber, it means it's charging the battery. A MagSafe 2 will transition from green to amber, but that does not necessarily mean that it is charging the battery. That indication will still be true even when it is not charging the battery, and that will still be the same state even when it is charging the battery. And then when the battery is fully charged, it will now go back to green. And then another thing also is, now this will be true even when the battery is not connected on the device. Do you understand? So even when the battery on the device, MagSafe 2 only, even when the battery on the device is disconnected, the charger will still be amber. This will not be true if it was a MagSafe 1. MagSafe 1 will remain green when there is no battery connected. It will remain green when it is not charging the battery. It will remain green when the battery is fully charged. It will remain green when it is stuck on SMC reset mode. And by the way, so okay, let's not push it too further. So that is the slight, other than the physical shape differences between the MagSafe 1 and the MagSafe 2. The MagSafe 1, when it is charging, it is amber. When the MagSafe 2 is charging, it is amber. However, it can also become amber even when the battery itself is not even present in the machine, which means it's not charging, but it's still amber. Now, about the differentiation between an original charger and the generic charger. With the original charger, when you connect it, there will be a slight delay before it establishes communication with the device. With a generic charger, there is not immediately there is contact with the machine, it pulls out power immediately, which is not good for the device. So this one, we are going to connect charger to it. You see there's a slight delay before it comes green, and then it's supposed to move to amber. If it doesn't move to amber, then it means that our battery is what? It's fully charged. Okay, so let us let's light this off again. Let's try that again. So that is green, and now it's okay. Okay, so it wasn't, I guess it wasn't properly connected. So let's try that again. So we connect, slight delay, we have green, and then it moves to amber. So that is how we should be. Now let's start the device. Ideally with the 2012s and above, even the 2011s, when they have the auto on options where you connect a charger and then the device switches on. But I suppose, okay, so I suppose, and that would be true in a situation where you don't have a battery connected to this device. So yes, now we power on the device, and then we have the startup options. Now from here, where it says choose network, we can easily confirm from here if we have an issue with the Wi-Fi. So we don't have to go to the client's desktop to confirm we have an issue with the Wi-Fi. So just going to click here, and then we can see we do not have options for Wi-Fi. So if it was also, this is another way you can diagnose an issue that could be software related, because if it is software related, it's not going to affect this stage. But the fact that it's here, we see that this is neither software, this is definitely a hardware issue. And because if it was software, we would have been able to pick it up here. So like, again, we don't have to go to desktop to get to see that we don't have Wi-Fi. We can just come here and then we see that we do not have Wi-Fi on the machine. So now let's shut the machine down and get to understand what is it that we are dealing with. If this is the first time you are taking out your screws on the MacBook Air, the A1466, you want to be sure that you are taking note of your screws in terms of the length and the positions of the screws. Okay, so the JTAG connector here tells us that this is a 2013 and 2014. If it was a smaller JTAG, then that would be a 2015 or 2017. So the device looks like it's liquid damage. So they said that they did replace the card already. So what we are going to do, even though they said that, we are just going to again replace the card to see if that is our issue. But the device is clearly liquid damage. You can see liquid. You can see corrosion around the board. So yeah. But just to be sure, let's just put in another card just to be sure. And get another card. Okay. And for the 2013 and 2014, so it's going to start. The fan will start and then stop, and then start again for the second time. That's normal. It will stop, and then the third time it continues. But that will only be because we had disconnected the battery. So for example, with the battery connected now, after the device starts, so this would mean this will be from a cold boot. After the device starts, if we've shut the device down for the second time, for example, and then power the device on without disconnecting the battery, the on and off, that's not good. It's just going to start. So when the device is going through your cold boot, then you will get that it will start the first time, stop, and then the third time the fan will continue, and then the device will pause. This is only 2013 and 2014. 2015, 2017 will not do the same thing. And then again, even at that, that is only to your cold boot. For example, after it's done that, should we shut the device down and then power it on? It's not going to perform that same boot process. Okay, so we see the card has been replaced and we still have the same issue. So I'm just going to shut it down to show you guys what I'm talking about. So now it's off. So if we power it on now, so if I power the device on, say it's not going to do the on and off, on and off. However, if it's going to be a cold boot, which is in any case there is no now now there is no power, so now this is going to be more like a cold boot, boot state. So now if I put it on, then it will perform the fan spin off and then fan spin off 2 times, and then the third time then it will continue. You understand? And this is only for your 2013 and 2014. So it will do that, and then the third time the device will start. Okay, so that's fine. Now let's take the board out. This is clearly a leakage damage board, and then let's put back our So those small things are things that you want to be aware of, especially when you're troubleshooting a device. Say, for example, if this board is out of the shelf and you are not able to tell that the board itself is posting, and then you see the behavior of the fan, you might misunderstand that for a quarter fan spin. So if your 2015 is to do the same thing, then you have a problem, because it's so you see on one board it's not a problem, and then another board it is a problem. So knowing which board is which, it's important. Clearly the screws are not properly matched, but that is fine. We don't have the fan duct, it's missing on this one. The fan duct usually will go over the heat sink. Okay, so let us put the board on the side. Okay, so this has been clearly worked on, and then we see that okay, there's been a wire for the backlight circuitry. We are not gonna, yeah, we're not gonna worry about that. So the two things, okay, this is clearly liquid damage device. So we see here that is the section for your source rail. Device powers on. We are not really worried about that. What we want to worry about is we want to see the region for your Wi-Fi. So now this is 3437, the board number, and just let's see if I'm just to be sure, that should be 3437. Let me see what's the board number. 34, is that correct? Okay, yes, that is 3437. That's, I'm not sure if you guys can see the board number here. Yeah. Okay, so let's open that up. 80-3437. On my channel, when I spoke about the troubleshooting processes, I spoke about the defined troubleshooting and then the undefined troubleshooting. So this is going to fall under a defined troubleshooting. I think is one of the videos of towards understanding your schematic. Now, what do I mean by defined? Now, the client has confirmed, and we are confirming that our issue it's Wi-Fi related. So what we are going to do is we are only going to focus on the regions of the board that are connected to Wi-Fi. Do you understand? Because it's defined. For example, if it was like a no power, if the device came and said it's a no power, there are many places we can start our troubleshooting from. But because this is a state that has already been defined, we don't have Wi-Fi. We're just going to go to the sections of the board that basically control Wi-Fi. So where we want to start, the first place we want to start is the Wi-Fi connector itself, correct? So this is the Wi-Fi connector. So we want to start from there. Now we see that when I say Wi-Fi connector, so I'm talking about the Wi-Fi card connector. So the first thing we want to do is we want to see, do we have power, or we want to see what are the requirements of this connector to function. Because if the requirements are not met, then the device itself will not identify the presence of the card when it's connected. Do you understand? So the first thing we want to do is we want to go to that card. So that card on the board is J3500. So we click on J3500. Now on the right here, we will see what is required for J3500 to function. The first thing we are going to do is we are going to check out the voltage line, which is power that goes to J3500 before we move down to data. So the first on the line is going to be PP3V3. Now another thing I also want to mention is this. Sometimes you may have circuitry that requires the part itself to be present in order for the voltage to be active. Do you understand? I don't know. We made a video of a 5-volt line, USB C issue, whereby 5 volt will be present only when it detects a USB device. But when you disconnect the USB device, then yeah. But this is not going to be like that. So with this one, whether the card is present or not, the voltages that goes to it will be present. Now, however, what will then differ will be the data line. So the behavior of the data line might vary if the part itself, which is in this case the card, is connected and functioning versus the card not being present. So first thing we want to do now is we are going to start from pin 1 because it says PP3V3 underscore WLAN. Now PP3V3. So what this is telling us, it means that PP3V3 we are supposed to have 3V3. We're supposed to have 3.3 volt on pin 1. We're supposed to have 3.3 volt on pin 1. So we are going to start measuring now. So what we are going to do is we are going to put back the card. Like I said, we do not necessarily have to have the card put back, but I'm just going to have the card put back as well as the SSD because I don't need it out. And where's the card? Okay, there we go. Sometimes I will have to, okay, I'm just going to leave the card out because in case I want to measure directly on the connector. Okay, so let's get a DC jack because this is going to be perceived as a code boot for the machine. So it's going to start, perform the same fan on and off 2 times, and then the third time the fan is going to continue. And by the way, you will see that there is no amber. That is because the IO board cable is not present. That's why. So you need the IO board cable to be present in order for the light to be present. And also with that IO board cable missing, the device will power but it will not charge the battery. Okay, and then the third time the device should start the boot process. Okay, so that's fine. So the first thing we want to do is we want to see if we have 3.3 volt on pin 1, and that we can easily measure here, which is the first pin here. We can measure for 3.3 volt on the first pin. Now we set our multimeter to voltage mode. The first we are going to place our black probe on ground, and then our red probe we want to put on the first pin. We're expecting to have 3.3 volts there. We have 3.3 volt. Okay, that's fine. Now the second one, Wi-Fi event underscore L, Wi-Fi event underscore L, we are not interested in that. Let us move to access point AP underscore reset underscore con underscore connector underscore L. So we are supposed to have 3.3 volt on that line. Let us see what we have on that line. So 1, 2, 3, 4, 5. So let's see what do we have on that line. So it's 1, 2, 3, 4, 5. We're supposed to have 3.3. What do we have? Let's say it's 0 volt. Okay, so Okay, so I'm just gonna the state the description itself says L, which is low, but I'm just gonna confirm if that's supposed to be 3 volt or 0 volt. Now let's move down to 18. So we have 0 volt there. We know that. Now we move down to 18. So let's see what do we have on pin 18. It also says 3.3 volt in S4 state. Let us see what do we have. The last pin, we have 3.3 volt. That is fine. Now let's flip the board. Let's flip it to the other side. Now we have measured on the connector itself. That is fine. We now wanna, so let me open the schematic so that it makes sense as to the next thing that I'm going to do now. What happened? The machine shut down itself. Okay, so let me open now. Let me open the schematic. So it's 820-3437. The next course 820, that's 830, 820. How much will I do? I'll be with you like now. So you see that first of all we started from by typing J3501. The next thing we're going to do now is to move to the component that is attached to or that is associated with J3501. So if we type that here, J3501, we should have it on the same page, J3501. Now, see where it says wireless connector? So these are the components that we're going to be looking at. We are going to be looking at U3560, U3510, and U3540. Now, U35, there are two pieces here. So one is going to say Wi-Fi. I'm not sure if you see that. So, okay, it doesn't say that, but one is going to play your Wi-Fi. Okay, that's 3.3. That is your Wi-Fi, your wireless switch, and then one is going to say Bluetooth. We are not going to worry about Bluetooth. However, sometimes you may have a machine that it works, Wi-Fi works, but Bluetooth is not working. Then in that case, you wanna come out to your Bluetooth, the section of your Bluetooth. But we are not going to worry about Bluetooth now. We are going to worry about Wi-Fi. So we have measured here. We did measure for 3.3 volt S4, which is on pin 18. And then on pin 1, we also did measure for 3.3 volt. You see where it says, you see here, it says PP3 V3 underscore 3. So the voltage that you're expecting to get there is what? 3.3 volt. Now, the next thing we want to do is we want to quickly, the reason why I'm going to worry about this guy, although I'm not going to worry about this guy, but the reason why I'm going to worry about this guy and this guy is because they are part of your J3501. J3501 is just a connector that holds the card. The components that makes that possible is what we want to check around now. So first thing first, we want to check around U3550. So we are going to copy that U3550, and then we'll go to our board view that is opened, and obviously we have the same board number. Okay, so the device keep going on. Let's remove, we're not sure if it's going to sleep, so let's just remove the SSD. That way it will not go to sleep. Okay. Okay, so we are quickly going to go to J3550. So we come to our search, and then we can just say, we just paste that, Command and V to paste. And so we will now identify what J3550 is doing. Just 1 minute. With the U3550, and then we paste it on our board view. So we want to see if all of the voltages are present on U3540. Most important thing on U3540 is, so if we come here, U3550. So the most important thing that we want to see here is the output. Because remember, whenever you're troubleshooting, you have to know when to move on. You have to know while you are where you are. So the reason why we are here is because we need a 3.3 volt underscore WLAN underscore R. So we're supposed to get 3.3 volt on output here. So if we get 3.3 volt on output and it's steady, we are not going to worry about anything else, because if we have output, it means that our SMC underscore Wi-Fi power EN enable is present, and then PV3 V3 underscore S5 is also present, because if these two were not present, this will not be present. So once we have this, we are not going to worry about this. So now what we do is we copy U3550, and then we paste it on our board view. This is U3550, and then on the board, that is going to be this guy. So on the other side of the board, that would be this guy here. Is that it? I just confirm. It's supposed to be two. No, this one, because this one. So this one will be this guy. Will be this one. So this one is the second one. So yeah. So they have under fuse around them. So what we want to do now, we want to see if we have. I think we already confirmed that we have 3.3 volt. Okay, so the output we can use this output here, this current sensing resistor. We can use that to see if we have a 3.3 volt. But obviously that will be when we have power on the board. So let's connect power to the board and then check. So wait for the board to start booting, and then we can fan to start again. That delay, the delay is not supposed to be that long. It's supposed to be like a slight pause in between. uh okay, might be something that we have to look into anyway. Okay, now the device is the board is starting, so let us see if we have 3.3 volt on the resistor here. And yes, we do. Okay, that's fine. Okay, so like I said, we have 3.3 volt. We are not going to worry about this. We are going to move from there. So the next thing we want to do is we want to see what's happening around U3540. So U3540, U3540, let's copy that and do the same thing and paste it on our board view. So U3540, and the reason why we are doing that is because it's also connected to our Wi-Fi. So U3540 is going to be this guy here. So let us see, what do we have on pin 1? We want to see if the voltages that are supposed to be present are all present. Pin 1, that should be present, but let's just confirm it. U3540 is this guy here, by the way. Looks like it's got a bit of a liquid around it, but nothing major. Okay, let's see, what do we have on and then also that looks like a broken part. We are going to confirm. So first and first, let's see. I suppose that is present because the board is on. So 5 volt S5 is definitely present. 3.3 on S5 is present. The next one is 3.3 V 3.3 WLAN V1. So there's supposed to be a voltage division there, I suppose. So let's see what we measure there. Yeah, that is fine. It's because there's supposed to be a voltage division there. That's fine. Yes, that's fine. And the next one is going to be access point reset L. So let us see what we have there. Access point reset L. That is definitely supposed to be high. Let's see. So we're supposed to have 3 point. So the access point reset L. So what that means is when that signal is low, what will mean that the circuitry will be in a reset stage, which would mean that it's not going to function when that signal is low. So we need it to be high. So AP underscore reset underscore L has to be high in order for the circuitry to work. So let's measure that on this guy here. So yeah, that's fine. 3.3, and then the other side 3.3. Okay, so and then pin 4 of it, let's see, pin 4, let's see, pin 4, uh, pin 4, the output of pin 4, what do we have? 0 input, 0. Okay. Um it says 0, but it could just be that we have a broken line because that is a pad and that is a pad, correct? So if this pad is broken, would mean that the line between this resistor and the chip itself is broken. So let us check the chip itself to see if we have voltage on the chip itself. I'm just going to briefly clean the chip. See if we have voltage on the chip. That might just be our problem. Okay, let's see if we have so we're going to check the pin itself on the chip. Even though we might not be able to get our probe to pin 4, we will try to see if we get anything on the chip. Yes, we do have 3.4. So 3.2. So the problem we're having is we do not have continuity between pin 4 of, so we don't have continuity between these 2 points here. So we don't have continuity between this and that. And as a result, we don't have output on AP underscore reset underscore con is low. So which is why, so while it's in that state, it will obviously reset the connector itself. So the connector will be in a state that it's not usable, or it's not in a state that will power the card. So if we check the output of that resistor, here's the output now, and we clearly see that we are getting 0. And then but then if we check the pin of the chip itself, we do have voltage. I'm just going to try and check that again. Yeah, we have 3 point something volt. Okay, so what we want to do now is we want to try to address that so that so I'm going to remove the chip. Okay, the chip is out. Now we are supposed to have continuity between pin 4. So we are supposed to have continuity between this and the resistor here. So as you see here, this and this are tied together. So that, and then we have a point, a probe point here. So we're supposed to have continuity between this point, and this point. As you can see, because they are what? They are together as one. So let us see if we have continuity, and that way we are going to place our multimeter in continuity mode. But I don't think we do, because if we had continuity, we are getting 3.3 volt here, but we're getting 0 volt here and 0 volt here. So which means you have a breaking line. So our multimeter is in continuity mode. That's a beep. So if we place our probe here and on the resistor, you see, that is, we are not getting any reading at it. So ideally, this and that is supposed to be 1. So we have a broken, so that line there, it's broken. So we are going to uh, put a solder blob there, which will allow us to communicate, to connect with it. Okay, so we're going to put a solder block there. But first thing I want to do is I want to put back the chip. Mm, okay. We could use a wire, but I don't want to use a wire. I'm just going to put a just going to put lead across it. Okay, that's it. Now let's see what it is that we have. So remember that signal was obviously low. So even while while we measured it here, we got 0 volt. So now we are going to check to see if we have something different. Okay, finally starting, it stops, and then it starts again. That's the second time, and then it stops. It should stop and then start for the third time. And this time the device should start booting. So now let's see if we have 3.3 volt, or see what is it that we have. And that's supposed to be on pin 14, which will be the second pin here. So this guy here, that will be pin 14. So black probe on ground, and then our red probe, what do we have? We still have 0 volt. Let's try again. We still have 0 volt. Okay, let's see. Why do we have 0 volt on that line? Do we have 3.3 volt here? 0 volt. Okay, it means our line is not connected. Okay, just let's confirm this. Okay, so our line is still broken. So let's adjust. Okay, I'm gonna confirm something now. Okay, we still have 0 volt, and this one here, 1.8. That's fine. 0. That is fine. Okay, so the chip itself is, the line is still broken. So let us try to move the chip a little bit to the line. Okay, that line is okay. So actually, that's one of the advantages of actually having to use a wire, because the wire would be quite easy, but yeah, choose not to use a wire. Okay, let's try again. see what we have now. Still have 0 volt. Okay, so we might have to okay, let's do this. Okay, and before that, let's check this. We might have to use a wire after all, but first let's see. Okay, let's check now. On this side, what do we have? We have 0 and 0. Okay, let's take it out and see. Okay. Do you have anything different? Yeah, that's the thing. So we're having a short. That's why it's you're not getting. Okay, so let's just remove the solder. We're having a short on that line. So I suppose the lead we use, we are making contact to ground somewhere. So let's remove that. So we are going to rather use there is a ground pad around there. So first, let's be sure that we don't have a short on the output without the solder So that being present. Okay, so we're done. So what we are going to do is we're going to use a wire instead. Okay, fine. We're going to use a wire. Okay. Make sure we don't have a short on the output. Then we use a tiny wire in between. Okay, so first thing I'm gonna do, get myself a small wire. Okay. chip I'm using is quite big. Nonetheless, we have to find a way to okay, let's do this. Shift it a bit again. Okay, let's see. We'll check that part there to see if that part itself is ground, because if that part itself is making its way to ground, then and then this one, that's fine, and that's not fine. Okay, let's see. Let's see then. Might be able to find a way around it. Okay. Let's try to add a small solder and see if we can get it past the short. Let's see. Okay, it's barely around the short, but let's see if it's okay. So it's not shorted. Let's see. We have continuity between that and this. Okay, we have continuity. Okay, let's put the chip now. Yeah, it's kind of majestic. Another one. Get another board. I think so. Okay, so that line, it's barely past ground line. Let's see properly. Okay, so to look like so. Let's say it's still connected to ground. It's a ground plane around it. The line itself is not connected to ground. Okay, so let's see if we have a 3.3 volt on this line. As expected. Okay, let's see if we have 3.3 volt. So red probe on ground, and then black probe. That should be the second pin. This one here. We still have 0 volt. Okay, so what's happening? Why do we have 0 volt? Let's see. What do we have here? We have 3.3, and then the other side 3.3, and then that side 0. Okay, so we also have a broken line. So we have a broken trace as well from uh, so from this point to the other side. Okay, so let's try to. So now we have 3.3 volt out. Before we add the solder in between, let's just confirm that indeed that line are the same thing. So we want to see that this part here is same as this. So continuity. Okay, yes, parts are same. So what we are going to do is we are just going to add a solder to it. Okay, so now we're going to check. We are going to check for continuity between that pin and the other side of the board. So it's going to be one probe. Okay, so we place one probe on the side here, and then we check the other side. Okay, yeah. Now that's connected. The fact that we get a beep, yeah, means it's connected. Okay, now let's check again. Okay, so our red probe and then our black probe on pin 14. Okay, that's beautiful. Now we have 3.34. Okay, so now let's see if we have any difference. We are going to go back obviously um, to redress the place, but first and first we want to see if we have Wi-Fi connectivity. We don't need the drive. We don't need the drive to confirm that, but we'll just put in the drive in place. We are only going to attach the minimum cables that we need to get the test in place. We need the cables. Although if you don't have the cables, the option that you will get, it's no longer going to be hardware not found. So I suppose before now, when you go to your operating system and then you click on the Wi-Fi icon, it should say hardware not found. If you do not want the hardware, just what you've done now. So and that was because the 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 reset, the AP underscore reset underscore connector L low would mean that it doesn't, it would assume that the device itself, the Wi-Fi, it's not operational. So if the cables are not connected, it's not going to say Wi-Fi not found. You might not be able to pick up the Wi-Fi's around you, but it's not going to say Wi-Fi not found or Wi-Fi card not detected, Wi-Fi card not found. So right now we just have the Wi-Fi cable connected, the Wi-Fi card is there, and then we are going to hold down the Alt key. So we're just going to wait for it to do its thing. That's one. The second time again. The third time we are going to hold the Alt key. Now we can hold the Alt key. What happened? Oh yeah, the cable got disconnected. Okay. And because there's no battery, it's gonna do the fan on and off thing again. Okay. Okay, device is on. See if we have Wi-Fi now. And there you go. So now you have Wi-Fi, and as you know before now, that was not the case. Now you can see, you can pick up Wi-Fi, you can connect to the Wi-Fi. So that's reset lab. And by the way, you can hear the fan being very loud. That's because the IO board cable is also not connected. So IO board cable also not connected will also cause the fan to be very loud. The difference, however, with IO board cable not being connected and the fans being loud and the machine itself, the fans being loud due to a sensor issue would be, even though this is not connected and the fan is loud, the device is not going to lag. But if it's a sensor issue, the fan will lag and the fan will be loud and the machine itself will lag. So that's a difference. So you may sometimes, the fan will blow full speed, but the cost of it will be of different, there will be different costs. So if the case of the fan being loud is because of the iPod not being connected, the device itself will work fine, except that the device is not going to charge and the device is not going to lag. But if it's a sensor issue, the device, obviously that will mean this is connected and the device will work but will lag. So you see the kind of, it will seem as if the trackpad, it's dragging. So if you move your trackpad this way, it's going to take time for it to, yeah. So it's enter. So okay, as you see now, the Wi-Fi is active. So in it already the video has been too long. So what we are going to do is we are, so say that, yeah, it's stopping, but yeah, Wi-Fi is now, it's now fine. So the issue that we had was AP signal, which was supposed to be 3.3 port, was missing, and that was because there was a broken pad between pin 4 of U3540 and pin 2 resistor of R3558. So we had to manually add a solder pad between pin 4 and RSSC, and also there was also a broken communication between R55 3558 to the connector itself. So which we had to again basically put a solder block between both sides. So put a solder block between this and that, and then a solder between this and this, and I see. And that's it. The device, it's now we have Wi-Fi. So I'm just gonna, so that the board doesn't, the video doesn't become too long, I'm gonna clean the board and then give it to Shahid to finalize. Okay, see you guys in the next one. Thank you.